Perfect. Thank you for being here. Come fast in, take a seat. Let's get started. My name is Max KORBACHER. I will talk today about sustainability, eats it or is eating it, depending on how you spell it. Why can I talk about it? Well, I'm also part of the CNCF Technical Advisory Group for Environmental Sustainability. It's something which I kicked off like 1 year ago. And we do kind of, I would say at the moment, like research, try to find out what is missing, try to incubate projects which filling the missing gap in environmental sustainability in open source projects from a cloud native perspective. And I do a bunch of other stuff, but most of the time somewhere I also need to earn some money and run a consultancy company. So I'm talking today about sustainability, and actually, obviously, that's not a new topic. If you look back, it's like 40, 50 years old, and for some people, it's maybe even like being an annoying topic. Live sustainable, do less waste, and so on and so forth. And there are also activities in the recent years which happen in the IT, but which were not that visible. And now, slowly, we see that the IT area is speeding up in this direction, getting more and more drive to build their own responsibility for sustainability. However, because we are moving partially into a cloud environment, we're moving into edge environments, we're distributing everything what we have more and more globally, it's getting not that easy to have just like a data center which I optimize a little bit. Because then even building a data center is not that environmental friendly in the end. So the big challenge nowadays is that, and there's different studies about, these numbers are very vague, but saying today global data centers, the global ICT, is causing around 2% of the whole CO2 footprint. Sometimes saying also the energy, or they consume the energy of 2% from the global energy spend, which is two different things, because depending on which region you are, it can be that 2% of power consumption means just like 1% of CO2 footprint, but it could also mean that you have 3% of footprint. The thing is that it doesn't matter that much because this number is like very unclear, and the last research on it is also like 4 years old. But what these numbers stated is that it will grow at least by 2%, looking into the last years. But there are also researchers from some universities which assume that the global energy consumption for ICT will grow up to 10 or 12%. Now, this is actually quite interesting because I was recently, before speaking today here, yesterday I talked with a friend of mine who was like, why you fly to London to talk about sustainability? Are you dumb? And I was like, well, it's pretty easy. The industry I'm working in, ICT, consumes the same amount of energy as aviation. Or in other words, produces the same amount of CO2 as aviation. Theoretically, if I sit the whole day in front of my computer or do a live stream from home where I need additional lights, I need a big screen and whatsoever, it's maybe not the same harmful as I take a flight back and forth, but it plays in the same league together with everyone else who's watching it, because I stream a lot of amount of data. This needs to be processed. It's getting streamed around the globe to different people. Again, it's not on the same level, but it's plays in the same league, right? And as said, we're talking about that data and distribution and countries who not yet that digitalized speeding up. So what we see nowadays in the consumption of the energy will grow drastically in the next few years, with every country who is generally make public to use the internet, to use computers more and more frequent. This is getting a very big problem because it scales up drastically. And last but not least, everything what we do causes somewhere CO2. Not always CO2, sometimes it's wastewater, sometimes it's other gases, it doesn't matter. But in the end, we are always talking about that we do something which is more or less harmful for the environment for a simple reason, because energy is not that clean yet. And we need energy for everything. So in the ICT world, there's one big thing. We miss actually the transparency of the power consumption of the carbon footprint for compute environments. You see there are recent changes in the last months, in the last year. Like if I would give 1 year back this talk, I would say like we do not have any transparency, except you're very, very interested in it. And this is like cutting edge technology. Thank you very much. But this has changed over the last year drastically. You maybe have seen in the cloud providers, they provide now some kind of carbon dashboards. They are maybe good, they are maybe bad. With some, you need 3 to 5 months until you get some kind of data, and then you still need to download it practically and do some hand math to find out how harmful your services are. Some others, like for example, Google Cloud, is getting way better. They even split you the information about different scopes, which I will explain in 1 minute or so. So they do their homework, and they want to be precisely in explaining you where does the CO2 footprint of your service come from. So the biggest problem which we see today is like really linking this data about the energy consumption to data about my energy mix. So there is this logic of like, oh, I can follow, for example, the sun with my services around the globe, so I can always use solar power. Yeah, you could do. The thing is, you have practically no way to calculate if this is really good or bad. It could be also that this country your data center is currently located in needs a lot of external power supplies, and the countries around it are all supply you with dirty energy. So it's a very, very difficult topic to go into depths. And for an end user, for a data center, for an enterprise, there is at the moment not that high interest to really grow into this transparency for one simple reason. There are no energy contracts which take into account how is your current energy mix. Like we think about it, like you as a household, you should maybe clean your dirty clothes at some time where energy is more cheaper. Yes, you can do, but the only thing what you do is helping an energy company to make more money. Because you as the end user, you will not get the benefit out of this, right? And this is something which we see also for the big enterprises. And that's where we need a lot of work, and that's why it's good that you are here, because then you are aware of, and you maybe can annoy some more people which you maybe know or whatsoever, just spreading the word. And I wrote also in the description about Kubernetes. Most people think about Kubernetes like a big container ship. There was also yesterday in one talk the reference, like, oh, look, this is so big thing. Yes, it delivers a lot of value at once, but to maintain it, it's super costly, and I do a lot of stuff, and that's a really big problem. Well, but this is not Kubernetes what it actually is. Kubernetes is more like a good Lego platform, something where you can have a unified system, where you can put your build blocks on top of it. It's more an API rather than a whole big platform, what people often misunderstand. And why this is relevant, and why this is relevant especially when we talk about sustainability, is whatever I can apply on this platform, I can utilize also across other cloud providers and on-premise. For sure, I need to take care about the servers and other compute infrastructure, networking, and so on and so forth. But all major cloud providers are so well integrated with Kubernetes that if I apply a lot of practices on top of this platform, it has a direct impact on my compute environments. And therefore, it's quite relevant for optimizing my infrastructure. Also, it gives me a little bit more scalability, flexibility-ness in some way. Other than that, there is no good implementation for specific cloud provider in optimizing the workload. You have to do this all by yourself. Every single step, every policy, and so on and so forth, which can be painful if you want to optimize something. So that's why Kubernetes is there. It provides this unified API for most of the stuff where you can bring it on top of it. And it doesn't need to be this big waterhead which you carry around. It can be very lean, can be very simple, but it can help you to arrange your applications in a more flexible way so that you could answer on some of the questions which we will start open by implementing Kubernetes and then gain the flexibility out of it. And there's one more thing, which I also said in the beginning. You need to understand scopes. When we talk about sustainability, we typically talk about scopes. What is a scope? Well, scope 1, which you can see in the middle, is everything what happens directly, where you're causing directly CO2 footprint. Most of the time, that is not so much, but let's say if you take your car and drive here, this is, for example, a good scope 1 example. A scope 2 is what for us and for most of us in the IT industry is the most relevant scope, for one simple reason. It's a passive usage of, for example, energy. And as we do so with our notebooks, which we have, with the servers, which we have, with the cloud infrastructure, which we have, this is where we can directly twist on it, where we can turn things off and on. And this is the most interesting part to understand. There's scope 3. Scope 3 includes everything what was caused when we produced something, like, for example, this MacBook or like a server. This is also called embodied carbon footprint. What does it mean? Well, when I produce a server, I need chips. I need some metal. I need some transportation. The thing was maybe shipped around the globe. So before the server hits your data center, or the data center of your beloved cloud provider, it has stacked up already tons of CO2 footprint, which it has caused during the time it was produced. And in the ICT world, it's counting in a way that we say around 80% of the whole life cycle CO2 footprint of a server just comes from its production, which is huge, right? And then we have the scope 3 indirect, which is all, or we say always upstream production and downstream to recycle it. This obviously can also cause a lot of CO2 footprint. What you will also see, and what I will always talk about CO2, about carbon dioxide. What I mean is CO2 equivalent. So I'm not really always mean directly the CO2. It can be methane or any other gas. But what we do is to recalculate it always to CO2 because it's easier to talk about one single gas than about 20 other gases, which you also can cause, which maybe are more harmful for the environment. So what we can do. Let's look at a typical stack which we work with. We have some hypervisor or hardware. We run our Kubernetes. We have tons of other components around, and maybe at the end some container and some software running into it. This is for us the most typical stack which we see nowadays. Kubernetes is here also just representing something. It can be Nomad, it can be OpenShift, it can be even just your serverless Lambda whatever environment, but there's some kind of engine in between which orchestrates your workload in some way or the other. What we can do nowadays super easily is to optimize for container images, reducing their size. Why does this matter? Well, you need to transport this image somewhere around the globe. If this is 1 gigabyte, you all the time need to copy 1 gigabyte. Every byte which you need to copy requires also energy to be transported. The smaller you get, the better it is. And obviously your application also gets better because it's faster in starting up and it uses less space on the server, for example. We have scheduling for containers for high density. What do I mean with this? Well, we see always that like when we have a Kubernetes cluster, people like to distribute it. I want to have it high available as much as possible. That's right, but most of the time you really don't need this. It's enough if you have one server and you pack it as full as you can. Not leave 20% of the space empty, but like go to 95, maybe 98%. If you know how your workload behaves over the day, you can, through predefined schedules, scale up your environment and be sure that you can catch every other hard workload which is coming in. Scale also containers to 0 means also the capability to scale down to 0, means that you can shut down servers. Now, in your private cloud environment or in your on-premise environment, this is something where you really need to go to the data center people and talk with them about it. Hey, what are you doing to shut down? When the server is idle, do you really shut it down? And the most modern servers are very easy to do, so it's an easy thing. What you never should do, by the way, in this is to set the server into an echo mode, because this echo mode doesn't do anything useful for you. The server uses still, for example, 200 kilowatt hours, but what it doesn't do is scaling up its capabilities. It has a limit. This is what an echo mode is nowadays. So actually very counterproductive. And, well, optimizing nodes or talking about nodes, we can optimize them going to ARM server or an AWS cloud to Graviton server. It's a big thing, and there's also a lot of very nice blog posts about it, also how AWS internally optimized, for example, their workload moving to ARM. And they are able to save 40 to 50% of their whole energy while getting 25% more performance. So in total, it's an almost 100% optimization. This is a very, very nice thing. However, to be honest, what we can do is a very old thing. This we could do last year and the year before and the year before of that, easy peasy. What we should do is to think about, do we really need containers? Can we schedule based on carbon data? Can we optimize because we know our data center in Helsinki has currently this and that amount of kilogram for CO2 per kilowatt hour and so on? Should we shift our workload? Or should we maybe scale down our solution because we don't need at the moment to process massive data? Very good use case here, for example, machine learning and big data processing, right? You don't need to train that maybe the data on the day. You can wait until the energy is getting clean, until the day, until your energy is getting into a state where you want to process and saving some CO2 footprint. We also need to think about different architecture styles. It's a discussion which I often have with my colleagues because we do also FinOps. So we not only optimize for sustainability or for reducing the CO2 footprint, but we also optimize for reducing costs. Most people will say, hey, if I optimize for costs, I will shut down, will reduce everything. I will automatically also optimize for my CO2. That's true. There's nothing wrong in that. But first, I would say there is a different mindset in it if you do the one thing and accidentally get the other. And there is no evidence that if I do not build an architecture for a sustainable IT system, that it maybe will not cost more than before. It can. Maybe I use different hardware, older hardware, whatsoever, which will be the right way. And yeah, talked about the improvement of the power management. As said, it would be cool if the echo mode of a server really can scale a server up and down in its energy consumption and not just put a limit on top of it. But this is something where people on Intel and so on work on. So let us have a look in this 4 simple steps so that I can give you some examples on this point, which you also can take away. The first one is to scale and to reduce and to right size. The most simplest thing which you can do. As said, it's something which you can do already the last years, but the best thing on it is this is the most efficient thing you can do right now. And it's super simple to do, and when you run on Kubernetes, it's even more easier to do. Why? Because all the tools are given. And projects like, for example, Kida, which is an event-driven autoscaler, implemented, for example, that they can react on custom metrics. So not only on CPU and memory usage or any other event which happen, but you can really push in whatever you want on your metric side. This could be carbon data, if you have, to scale applications. And this can lead to a very drastic reduction. If you compare this to the optimization which we do in FinOps, we minimum talk about 30% of reduction. If we go very, very hard and the application is very, very flexible, we say 40, 50% is easily possible. And this is very, very helpful. However, we need to understand how much energy is our applications actually using. And for this are currently 2 very interesting developments happen. The one thing is Kepler, which is some screen on the left side from a Grafana dashboard. And on the right side, we have Scafandre, which is developed from a French team. What they both do is, and this requires actually that your Kubernetes is in some way running on a virtual machine or QEMU, doesn't matter, but it must be something where we can really talk to the kernel in the one or the other way. These tools practically read from the kernel all the system available information and try to match it in the background with the processes which are running on Kubernetes, for example. Kepler is very fancy in this way. It does it with the eBPF, for example, so it's very precise. Scafandre goes more or less a similar way. However, whatever you use, you suddenly have the information about how much power does your application require. And this is something where you can act on, because if you monitor this over time, you understand how is the power consumption. And if you start now to think about also any other approach to optimize your architecture, to optimize maybe which algorithms do you use, or maybe you want to change the programming language and whatsoever, would not do it, but come to this later, you would see that maybe you can perform or optimize the power consumption overall. So you have suddenly something where you can act on. And then there's something what you also need is that you need to combine this power consumption information with your current location. Where is my application running? The cloud is not a valid answer anymore. The cloud can be anywhere. Tell me the exact location. Which data center you're talking about? And then there are some tools like the energy map, for example, where I can see, like yesterday evening was in Great Britain, the energy mix in not that good, I would say. 312 gram per kilowatt hour. It could be better. I come from Germany. You see, I'm even more brownish, so you can bash me for that. But you also need to understand, for example, France, which is very green, is not that green. They have tons of nuclear power plants on the border to Germany, and therefore they do not need so much coal and gas. So yes, the energy overall is very clean, but they have to deal with another problem. Right? So that's why you can look also into Scandinavian countries, but also there, they do not have the real Green Deal. The major power supply in Scandinavia or in Sweden, for example, also comes from nuclear power and not through water and wind and whatsoever. So now you can do all this combination and you have suddenly the possibility to identify, hey, how much carbon footprint does my application really have? However, this link is currently not automated. So good luck with Excel sheets and maybe Python scripts, but you will be getting close to find a good approach here. And sooner or later, your companies most likely will even enforce you to provide this information, because in Europe there was just like recently an act released where companies from bigger sizes needs to do statements on how is their carbon footprint, what they do to optimize it, and maybe for an automotive, this is not that relevant to look into the IT. But what is with insurances and banks? The whole business runs practically on servers. If the servers are shut down, the business is done. So it's getting relevant in this industry in the most strongest way. Changing hardware, we talked about it. ARM is a very good approach here. I know not with every solution or with every application that's possible per se, so you need to check if it's really, really possible. But you know, it just is a question of time. And what we see here is that, for example, running stuff with WASM could be one of the things which might solve some of these problems. Not because it's only the super cool new fancy technology, but because it comes with a lot of upsides that when a WASM runtime can on one kind of architecture, it practically can run everywhere. So I can port it from the server. I don't care at all if it's an Intel or an ARM or an AMD chip or if it's a GPU or whatsoever. As long as the runtime supports it, I can just use the same application and throw it everywhere. So I have suddenly a very big flexibility. With a container, I have to rebuild the container every time. Yes, this is not the biggest effort, but then you carry around at least 3 to 5 images, which you need to maintain and test all the time. So you can also make, for example, your life a little bit easier on this part. And yeah, obviously you can schedule everything, for example, to Finland, which in this regard is very good. But I think if whole Europe would suddenly move all the applications to Finland, we need more data centers in Finland. And then the downside of data centers is cement, which is one of the heaviest pollution provider out there. So whenever you see somewhere using cement for building something, that's not good. Better use wood or something. No, wood is not good. As said, everything has some downsides in it. So again, could WebAssembly also there a relevant game changer? Maybe. It's a big bet. I like the technology also for other reasons. Building serverless platforms with it, so flexibility here again, is a very nice thing with it because we have startup times from around 50 milliseconds, which is like snap. The images are super small, which is also great. And it's always, or most of the time, scales to 0. So if an application in a WebAssembly runtime is not needed, it's not running. This means that my platform, which I'm running on, must be able to breathe a lot, must be scaling fast, and so on and so forth. So not every cloud provider is the correct solution for it, because they need most of the time like 5 minutes to start up a new node. But you have other cloud providers, and especially infrastructure as a service provider in your regions, which manage to start a server within 30 seconds. And then we can really talk about like, oh, I need more compute instance, tick, scaled. I can reschedule all my workload, no problem. It's getting very, very agile in this way. Adjusting the system architecture, well, This is, I would say, the most complicated thing which we currently could think of. Why? Because we do not have enough information on it. We do not have studied enough. We do not try to find out or haven't seen enough implementation from the big tech companies, which architecture styles, which changes have which effect on my application landscape. We need some research on it. I know that there's a couple of companies working on this. They have released, for example, their sustainability guidelines, giving some directions and principles into this ways. So we are under the way, but there's again no evidence. And this is sometimes like the most relevant thing. Just because I think that something could be better, like shifting my workload from Germany to France, it doesn't mean that it is better because I have to deal with some other downsides, for example. And in the system architecture, what we can say for sure, we need to deal with data smart. Somehow we treat cloud environments and data as an infinite resource. And it also more or less kinda is. We always can talk here about at least exabytes of data which we can push to a cloud provider before the cloud provider gets nervous. The thing is, every gigabyte you need to store somewhere, which means somewhere has to produce somewhere the storage. They have to transport it, implement it, they need space for it because data literally needs in the physical world space somewhere. It's nothing else when you just do grocery shopping, right? You need to store it somewhere. And we need to get away from this, like, oh, I will first collect all the data which I can get, and then maybe I will later sort it out. Maybe later it will be relevant for me. No, if you collect all the data, think about what you really need. Do you need the trash lines which are there? Do you need all the useless log files and whatsoever? Or can you throw it away? Because if you reduce this is the best thing which you could do in your current architectures, because there's a clear evidence. And funnily enough, this is also like one of the recommendations for a private person. Who of you has like 15,000 cat pictures of his cat? 9? Damn it. Maybe of the dog or pet feral, I don't know. Exactly enough, it would be the best thing to reduce this 15,000 maybe to 1,000. Because again, it's somewhere uploaded, maybe to the cloud, running somewhere, stored somewhere. And how many pictures do you have where the cat is moving fast and it's like actually trash? Just delete it, because you really, really don't need this picture. You even don't make something cute out of it, but you just have it because maybe, you know, need it in future. So this is something which you can do as a private person too. If you need there some help, and it depends on which domain you're on, the Green Software Foundation has defined some patterns, which you can find on the Green Software Foundation pattern catalog. Currently, they have classified it between artificial intelligence, but this concludes everything like big data and machine learning. We have cloud, there you can find all the kind of topics for Kubernetes and how to optimize on the cloud provider. And you have also a web section, which is more about like the front end and how you can deal with like playing out information to your end users in a most sustainable way, and what are the do's and what are the don'ts. This is a very good starting point. And the best thing is, if you have an even better idea than that what is written there, you can just like open it on GitHub and push a PR and say like, I would change this and this and this. We have seen this, we need to change this. And then last but not least, for those of you who are playing more with the software than just with the infrastructure, we need to discuss about how we can optimize software itself. And again, this is a field where it's getting a kinda tricky, because we know, for example, that different sort algorithms obviously are for the one kind of data faster than for the other kind of data. So we can plug and play the right sort algorithms. But we nowadays we need to deliver fast some kind of functionality. And it doesn't matter if this now needs 1 second or 3 seconds, but like just do what works and fine, let's move on. So we spend less time to really focus on writing the right things and just like focus more on like solving the problem. If you have solved it following principles as security, as sustainability, and so on and so forth, is another question. And this is a cultural problem in the end, because we need to go back to the point where like we have time to think about what I'm writing here. Does it make sense? Or maybe do I need to spend 3-4 more hours to optimize it and to be better in what I have delivered and not have always this continuously time pressure? I'm pretty sure most of you have most likely developed something during a Scrum process, and then like in the end of the day, someone's like, "Oh, what you have done? Tell me, blah blah blah," and it's like, no, I maybe need some more hours to think about to make the solution better, which I've implemented, and not just keep pushing things. And we need to take a look also on the build process, because, and I come from the Kubernetes environment. I was 3 years of part of the release team. What we do is practically every PR is getting tested end to end, more than 7,000 checks. Every commit is getting tested against some linting, against some rules and guidelines. And whenever we build and release something, this takes hours. There's several thousands of checks going on continuously. We run more than 250 Kubernetes clusters in parallel to test everything what's possible. They are running in a Docker environment, so they're quite small. It's optimized, but it's still a very, very large scale which you're going to testing on. And there is a work group in the GitOps and CD working group within the Cloud Native Computing Foundation, which is currently trying to find out, hey, what are the patterns where we can optimize the process we are building our software, where we're building our containers, where we're shipping our containers, and which solution actually has which impact, to try to understand this a little bit better. There was like yesterday, I think, or the day before, there was a CDCon in somewhere in North America, and they have compared, for example, Flux with Argo. So the green thing is Argo CD as a GitOps tool, and the yellow one is Flux as a GitOps operator. And in idle time, you see already a slight difference between them both. Argo used more than the double of the energy just for doing nothing. Okay, it has a front end and so on and so forth, but there's already just a difference for that. Because the funny thing is, GitOps tools most of the time don't do anything. So this is relevant to us. And what they also have shown, when we have one concurrent deployment, you can see how Argo spikes up while Flux literally don't care. And this is super interesting, because I need to say, I'm sorry, but I'm actually an Argo fanboy for some kind of reason. I never liked that much Flux, but in the terms of sustainability, I should switch, because my pipeline suddenly looks actually very horrible to me. And yes, it's an incident that the lower energy consumption is green than the other one. So this is something which we could do and could think about, but you see that you can have a quite strict effects on it. However, there's also this super famous picture. It's maybe circling around. Hey, you all should now write your code only in C or Rust. Forget about JavaScript and Python and whatever else you want to use. Never come to the idea to use Lua or Perl. You're destroying basically the planet with it. Yeah, the thing is, please forget this. It's not that it is not true. So at some point in time, this was correct. If you sit down and try to understand where this comes from, this was done more than 5 years ago. And at this point in time where they have done the research, some of this programming language and the version which they have used were already also a year old. So whatever else you see here, this is 6-year-old information. And I know, for example, like in the environment of Go, they have drastically improved performance and power consumption. And there are libraries who reduce drastically the need for power and whatsoever. It is a good direction, but when you ever see this, give it a smile and forget whatever else is now talked on it, because it most likely is some kind of incorrect. Another thing, and this plays very well together, is with when I know how much energy my application requires and how much CO2 per kilowatt hour I have in the region the application is running. Then I can use, for example, the software carbon intensity specification from the Green Software Computing Foundation and calculate for my application a score. Why the score is relevant? Because, again, I have a KPI where I can start act on. I can try to understand how much energy and how much CO2 output my application has. It even thinks about they call it a functional unit. You can also call it a scaling unit, right? So if you fill this a little bit out and you say like, okay, my score is 2 per user or concurrent user which I have, then this means like with 4 users, it quadruples over the time, and so on and so forth. The thing is, this is like more like a framework. You can play around and try to identify how do I get my energy data, how do I can fill my carbon emissions, how can I fill the M, which is like the embodied carbon, which is the hardware and the data center which I have. So it's not super easy to get there, right? You need to do some research within your company, within your service provider, to understand exactly all the different numbers which you can put into. And it has the flexibility to react on like, what is the scaling factor? We're working here with one open source project together, which does not scale linearly or exponentially. It scales because of the complexity of a policy which you can write as an end user. To be honest, we have no idea how we define this. I don't know. I would need to calculate it per policy or what. But this explains also very well how complex it can get. However, when you have this score, as an example, it's really something which you can measure over time, from release to release. And then you can think about what I can do better, where I can change something. For sure, maybe it helps to move it to another data center. You will see the impact here. Maybe it helps. Another cool thing is that the SCI is currently being pushed and try to be pushed to be officially released as an ISO standard. So at some point in time, suddenly all companies will get very hot to have this per application. So it's good to think about it already maybe now, because with the European regulation and maybe having this maybe as an ISO, this will all come sooner or later very well together. Process matter. I talked already about it from the GitOps tools. You do not need to run checks on every commit, where you can maybe check it locally. You do not need to build every commit to a container or whatsoever. I know Google does this maybe. I know other big tech companies does this. But this is also partially not true anymore, because also they have optimized all their pipelines. Because if you run a global service with thousands of services and you continuously would need to rebuild this, you would be dumb to do this continuously. You would spend millions just for like having once a green check mark somewhere, right? So there's other ways how you can get better. And your software development lifecycle is one critical part in it, where you can think about what are really the needed and what are the unneeded steps, and where I can really boil it down to the points like, hey, maybe I don't need to run the 7,000 tests every time, but just only when I want to cut the release. I hope you all know still Mythbusters was a very cool series. There are a couple of kind of myths out there when we talk about sustainability in the IT. The first thing is, oh, we can time shift our jobs. So we go from one time frame to another time frame because at this time the energy is more greener. As I explained to you earlier, that's theoretically correct, but it doesn't change anything. It maybe changes the energy demand to your cloud provider or to the energy provider of your cloud provider, of your infrastructure, but it's something which everyone has to do. And the problem is, if everyone does this, you will not have enough baseline, enough green energy baseline, which can capture all this change of the workload at the moment. So it's maybe a half of the myth, but you really need to think twice or thrice time about it to understand, like, hey, is it really what I want to do, or can we not do some, or focus on something else? Because also it's sometimes a little bit difficult to do so. The other thing is like this relocation or following the sun. Going around the globe, sure, no problem. Because every country on this planet has solar panels on their fields? No, every country do not have this, and not every country has water power or has wind or all of this together, right? In the best case, you really will save some money because different regions are differently expensive, as I can tell you from a FinOps perspective. But the bigger or the greater the amount of data is you need to shift around the globe, the more problematic is getting to calculate how much energy you really use. There's a reason why cloud providers let you pay for outgoing data, not only just for fun, but because you use the network infrastructure, and the network infrastructure they use is quite big, it's quite costly. And therefore it also consumes a lot of energy. So if you have a highly distributed application which doesn't need any data at all or just process data in time and then that's it, sure, you can shift it as you want. That's not a problem. Then use edge services and whatsoever, problem solved, or everything cool. But if you're talking about like a big fancy topic at the moment is data mesh. I want to produce big data all around the globe and maybe shift some part of it. Well, the idea why I want to store the data not in one central data lake anymore is A, because it's super expensive, and it doesn't make sense. Just, again, to collect random data does not make sense. Get your data where you need it, process it, and maybe delete it. But relocate your data just because you want to save the planet is most likely not the way to go for you, because you will cause actually more energy consumption. Yeah, and the last but not least, I also talked about it, optimize for costs. It will optimize also CO2. This is given. But there's playing two things into it. We would call it greenwashing. When you say like, oh, look, I've saved 30% of our costs and we are now more environmental friendly and please give me my green badge and whatsoever. This is greenwashing because you use an incident of something else, what you did, to make marketing for yourself. If your intention is to really reduce the CO2 footprint, and by the way, you also save some money, you can greenwash whatever you want about the money, no one cares. But the other way around, it's a different mindset. And as I explained you also with the architecture part, it can be that the infrastructure is getting more expensive if I want to optimize it for saving carbon. However, we need some more research on it, but there are some good ways where we can kind of prove this and see this, for example, with AWS Lambda, which is like getting so heavy with a large scale that it actually doesn't make sense anymore. And then last but not least, there's a sustainability paradoxon, which is actually quite funny. So we talked about, hey, let's optimize the hardware and everything is good. ARM servers are great for it, Graviton is great for it. It needs up to 60% less of the energy, fantastic, this saves a lot of carbons. It provides us more performance and overall it has a better price ratio because it's also cheaper somehow. All cool, so we just have to go to ARM and the world is getting green, right? Well, maybe. But there's also the other thing that it actually would make sense to use the hardware which you have as long as possible. As I explained you with the scope, the biggest problem with your hardware is not the energy which you use, it's that you use the hardware because of its production. So over time, it would make sense to not run the server 3 years, but 5 years, or as long as it will burn and break into pieces, but this would be the correct way to do. However, on the other hand side, it means that you need to run old hardware which needs more energy, which is also not that good. So the problem is actually quite stupid, because I want to do the better things, but I need to produce the new things, which is also not so good, or run the old things, which use more energy. It's a very stupid problem. So overall, yeah, this is also a good point. It depends also on what we're talking about. Cloud provider, you most likely even don't have any hands-on what happens with your old hardware. If you run your own environment, you maybe need a new data center. As I explained you, cement, beton is the most horrible thing. It's even horrible than flying around, and it's even more horrible than running servers. What is really destroying the planet is the beton ground floor where your servers are standing on. It's so stupid, but it requires so much energy and produces so much carbon footprint. It's really, really big problem, which you need to calculate actually also again into if you want to optimize something. So it's a very stupid problem because whatever you want to optimize in the one or other way, you always have somewhere also a problem appearing up. And this is something where every one of you or everyone who wants to work on this topic, and especially for the companies you're working on, you need to identify what is the right way. Do I have my own data center? Okay, cool, perfect. Let's build a private cloud which can run infinitely long the old hardware. And whenever we need to replace something, let's do it with ARM. Could be an option. Or do I go with a cloud provider and host it in a cheaper and greener environment, and then use also just ARM Graviton servers because it creates a demand towards the cloud provider to buy more of this newer hardware. No matter what you do, you should do something, at least something. You have seen there's plenty of options where you can start. You can optimize on your infrastructure and on scheduling some of your applications. You can think about how to optimize your software itself. You can think about your processes. So you don't even need to be like the person who is anymore so deeply involved in building or designing software. It can be also that you're maybe just a project manager or whatever who has an influence on the process overall. So there's plenty of options which we can think of where we can start with. Because whatever scope we reduce, it's better than nothing. And there's a few people in this environment, also when you search up for more topics around sustainability, which will always bash you and say like, it doesn't matter what you do on scope 1 and 2, scope 3 is a real thing. You all have to do something on scope 3. Theoretically, this is correct. But here's the thing. If you reduce the demand of scope 2, it means you reduce the demand on new hardware / scope 3. So working on scope 3 carbon footprint topics means that you reduce passively also the demand on scope 3. And this is what we all can do. As said, delete some unneeded cat picture, perfect. The iCloud provider needs less space and storage for it, right? To drive this change within the Cloud Native Computing Foundation, we have founded a technical advisory group for environmental sustainability. And what we do and what we try to do is to identify these blanks which we have, like for example, measure the power consumption of an application and fill it. Or we try to find the projects who have maybe a solution, but where there's maybe 1 or 2 genius people somewhere around the globe doing this in their free time, and we go to them and say like, hey, I have there a community of 200,000 developers. Let us help you to make something which we can scale up, where we can bring you people who are interested and incubate all your crazy ideas and make it somehow come true. And there's other cool projects. Green Software Foundation, they have a lot of ideas about how I can do my patterns better and working on this SCI specification. There's always climate, which is a little bit more like an umbrella, more high level, also working with data center providers together. LF Energy is more in the energy sector to find a way to be more flexible with the energy consumption, stuff like this. And Project Silver is an open source project, actually in the telco market, but one of the 4 key pillars for Project Silver is to reduce power consumption in the telco market. Because all the antennas which you have on the roofs and which provide you 5G and whatsoever use tons of energy. Oh, once too fast. If you want to chat with us or join us, you can find us in the Cloud Native Computing Foundation Slack channel. We have a Tech Environmental Sustainability channel. You can also find us on GitHub. And we also have, yes, it's a very old school way, but a mailing list, because somehow people read more mailing lists than Slack notifications. Therefore, thank you very much, and I'm happy to chat with you more about this topic.